Hola, bona tarda a tothom. Buenas tardes, good afternoon everyone. So yeah, we are here for the NetBCN new meetup today. As you can see, we are working mostly from home as everyone around. So yeah, let's wait for just 1 minute and we are gonna start the live stream. Hopefully everyone is good at home. Okay, so let's start today. So as we commented, we are here in the NetBCN community, that is a local community around networking technologies based in Barcelona. As maybe you already know, these days we are mostly working from home, everyone, and we are not allowed to go to the social events and just do what we usually do, just to encourage people to exchange knowledge and also learn new topics around. So today, just to overcome this limitation that we had, and we are going to have for some time, I guess, we thought that it would be a good opportunity just to go forward and try this kind of format that we have not done before, because the idea of the meetup is to encourage the participation, the face-to-face participation, the real networking. So in these circumstances today, the idea will be that we are going to have a shorter event, only one. Not going to be a presentation, it's going to be more a kind of a demo about how you can start automating your networks using Python as a example of a coding language. So for people that doesn't know about NetBCN is a community around networking in Barcelona. There is a web page that we invite you to visit, netbcn.cat. You have also the English version or the Spanish one, so you can get the same resources. And it's a kind of a not super big community, but for the topic that we are talking about, it's quite interesting. We are more than 500 members. I remember that it's around 518 more or less. Yeah, a good number, and we have organized so far almost 20 events. I guess that this is the 20th one. Also, to foment this kind of interaction, we also have obviously we have a mail, but also we have a Slack channel that you can just click and join through the web page, and there is also a good conversation around just about ideas, about any topic that you're interested, or actually we are actually sharing some job opportunities that you can find around in Barcelona, because basically this is focused in Barcelona. Apart today, as we are doing this kind of not real-time interaction, we are enabled a Slack channel that you will find in the chat, in the Slack. If you go there, there is the channel stream-26-03-20. That is just for you, just to share any topic, any question that you would like to ask me during the presentation. So yeah, without any other delay, let's start with today's session. That is going to be not just a talk. There are no slides at all. Basically, we are going to work on some demonstration for a simple entry-level approach to understand how you can handle devices programmatically. The session will be driven by me. My name, for whoever doesn't know me, I'm Christian Adey, and I'm based here in Barcelona. I'm a co-organizer of this meetup, and I have been working lately for Cisco Systems as a software network engineer, basically focused on automating networking stuff around the internet. So what is this about? Today, what we are going to do is a kind of simple exercise that we are going to use as a main resource, a GitHub repo that you can find in github.com/chadey, that is my nickname, and network_automation. And this network automation training that I created a few months ago, that I built basically just to summarize some content, some material that I have been building for some classes, demonstrations that I have been running. And this material everything is here, is in this GitHub link, but you will also find a link to a video streaming or online training platform that called Udemy, and you here can find a free link for this same training that is based in kind of videos that I recorded in Spanish just to facilitate sharing this kind of knowledge. So let's go. Yeah, you can go here in this repo, you can get the same information, github.com/chaday/network automation. Feel free to ask any question that you want in the chat, and I will just have a look from time to time. So what we have here is a background environment. Background is a virtualization facility that will facilitate us just to using VirtualBox as the supporting framework to run the virtual machines in our local laptops, just to spin up some devices that background will be just coordinating, orchestrating all of this, just to spin up the devices and get the configuration just to create some kind of environment. This environment is pretty simple. You will see here in this nice picture that we have in the bottom part, you see just a Linux server. You can have to imagine this as a management. This kind of your out-of-band connection to the network. And then there are two routers. In this case are just BIOS that will be running as router A and router B. They are connected through the management network to the management server, and they are connected through a link. You see in Ethernet 2 and Ethernet 2 in both routers, there is a link connecting. This link initially is unconfigured. So the point today is that we are gonna work. The training has other examples, but we are gonna focus today basically on Python. Why Python? So I'm gonna say that Python is kind of an easy to read and write coding language. It's easy to understand what you are trying to do with Python. There is not a lot of boilerplate code around, and gives you a simple understanding of what's going around. And also for networking, it's also good to know that there is a lot of resources. There is a lot of libraries. There is a lot of big open source community around. Just to name some of them, one that we are going to work today with, there is, for instance, Netmiko, Napalm, and also other libraries, more general speaking, like Jinja templating, that will be used today for just create configurations. And I believe that Python is a good tooling just to unblock you to a first automation tasks, to create automation tasks that are quite simple, and also not because network automation has different stages, and sometimes maybe you feel your network is not ready to accommodate some kind of abstraction, some protocols. Your network devices are quite old, the devices that are not ready for them. At the end, all the devices have SSH access, and in based on of SSH, Netmiko, for instance, is a library that we are going to check today that is based in Paramiko and give you an extra level of abstraction just to facilitate interaction with these devices. There is no implementation for every device, but there are a lot of them implementing because it's quite simple. There is not a lot of abstraction. It's just how to submit a command, how to exit some config mode. The simple actions that you will do in the CLI are translated to kind of Jinja methods. We are gonna actually see a different library that is Napalm that goes a step further and abstracts this a bit more, actually giving you, because one of the things that you will see the difference between Netmiko and Napalm, and this is kind of a spoiler, is that Netmiko gives you all the raw information from the CLI. But in case of Napalm, we're going to see that this is an effort just to provide a more structured data that could be reused for other tooling. So let's go for it. Don't talk too much and just show the code. So how to run this? Basically, if you clone this repo, you're going to go to this place. You will have something like this. So Here we see all the resources. Let me simplify this. And basically what we have is a background file that, as I mentioned, is like the file describing what are you gonna orchestrate on your environment. So which are the machines that will be spin up, which is the configuration, and so on. Background works for your laptop and works for other environments, the cloud, wherever. So in this case, if you look into the background file, you will see something like we defined for one router, so we spin up a router with a specific image. We are using VirtualBox as the virtualization lower layer just to spin up these instances, and there is extra configuration, for instance, for the server. A part of spinning up, we are actually providing some kind of provisioning, copying some scripts, some files, just to make it easy, and reproduce the picture that I mentioned before, that is this one. So we are going to have two routers connected by a link and configured, and then a management server that connects to both devices. So to start this, what we need to do is do a background app. As easy as we clone the repo, we go into the repo in your local laptop and background app. This is gonna take a few minutes. In my case, not gonna take so much because I already downloaded the Ubuntu image and the BIOS image that will be used to spin this up, but it goes just one instance at a time, downloading the image if it's not there, provisioning, and making this happen. This is gonna take a few minutes, I guess that is 2-3 minutes, but not too much. And at the end of this, we are gonna have this kind of network. And from now on then, what we are gonna do is go into the management server and try to do some kind of automation. Just as an introduction, we are gonna start first talking about Netmiko. The exercises that we are gonna do today are in the examples folder and in Python. So in Python, there are 3 examples that we are going to go through today. And actually there is an extra one that is an assignment that we are going to do as the last topic. So just a simple comment, because we are going to do everything in the console. Why? Because these scripts are designed just to facilitate a demo. So you will see that most of the commands are just saying, okay, the command is this one, and I run it manually. So it's kind of it's not a typical Python script, these ones, because it's more for demo purposes. So we are going to start exploring first how this works and try to understand. If we have to go to the code, we are going to go. But if we don't have to, we can just start working directly on the scripts and the standard output that is good enough just to understand what's going on behind. Let me check in the meantime if there is any question, any topic in the Slack channel. Okay, I see already someone joined the chat. Feel free to ask anything that you would like to explore more, or just any question, any topic. I will just spend the time that we need to understand it. It's not going to be so long. I guess that with 45 minutes, everything will be ready to go. So we have time to explain whatever we have to. Let's wait for this to be provisioned. As you can see, there is a base image, and from then we just built some extra stuff on top of it. It's a simple environment, but I believe that to start understanding how this works is good enough. So you will understand that we are going to go into the devices, interact with them, understand which are the differences, the different options that we have to work with, and depending on what you have to do, maybe one library is good enough, or you have to go for another one, or sometimes you have to do other approaches. A part of Python, maybe you are aware that there are other approaches to network automation. Maybe you are aware of Ansible, for instance. Ansible is actually another automation framework that is more focused on... So basically the point of Ansible is that like someone has already created the modules, is actually the name, the modules that in Python, in the same coding language, but someone has created these modules that you are going to use only defining the data. So you are defining the input data, and the modules will do the work for you. In this case, if we go directly to the source, to Python, we can prepare our program to make what has to be done. So let's go and check what is the background status. If the demo is working fine, we are gonna see 3 devices and all of them running. So let's go to the first one. That will be like our source of all the scripting. Everything will be done here in this server. It's a regular Linux server. We go to a folder that we already copied into the device, where we have the examples. So we can go to examples, we go to Python, and here we have the examples that I presented you before. So let's start. We are gonna run the first example, and this is gonna work like this. So in this example, we are gonna explore the Netmiko library. As I presented you before, it's kind of one of the most famous libraries because it's useful for a lot of devices. It's broadly used in abstracting easy interaction with the CLI. So we are gonna keep pressing enter to move forward. You see that is prepared just for demonstration purposes. First topic. So Python is a coding language that comes with system libraries, but it has not everything. So if we want to extend the capabilities of our code with an extra library like Netmiko, because you have to understand that not everyone in the world is interested on networking, even it's an interesting topic, but it's not the fact that everyone is interested on this. So Netmiko is not installed here. So to move forward and to be able to use Netmiko, we have to install it. So here we have the command that we have to run, that is pip install Netmiko. In this case, we are installing a specific version. This is gonna go to a specific repository just to fetch all the dependencies of this library. You will see around that in Netmiko, Netmiko needs, this library needs other libraries. This one, specific versions. So all of this has been installed here. Once this is done, let's try to run the script again. So now we are comfortable that Netmiko will be imported. So we are going to import Netmiko. How to do it? Import Netmiko is the key that will do the job. Don't worry if you are not seeing any Python code yet, because we are going to see on the last exercise. It's a more interesting one that is just focused on doing some automation task. Here we are just spending some time understanding how it works around. Then when we have the library imported, you have to understand that what we are doing here is like calling the same commands or same code that we will be running directly in Python, but in this case we are representing easily on the screen. So now the next thing that we usually do when we have a library imported is understand what this library is offering you. What are the methods that it offers to you? And this case is just doing this command, dir Netmiko. So you see that what it returns to us is a lot of different options. So like F5, you see Arista, you see Alcatel, you see A10, Cisco, Sienna, BIOS, Ubiquiti. As you can understand, these are not just drivers that are prepared to be interacting with this kind of devices. As you can see, there are a lot of them. I guess that most of them. Huawei, Fortinet, HP, Juniper, just Linux interactions, a lot of them. Then we see a specific class that is one of the main classes, that is the connection class. So the connection class is the one that will give us the actual interaction with the device. So what we need to connect to a specific device? One of the important things is the device type. You can understand that in order to select which is the driver that we want, we have to say, yeah, I want to connect to this device that is this kind of device, just to tell the library, help them to understand which actual code has to be run. Then we only need the host, so the target, the IP or full qualified domain name, the username and the password. And we are going to create all this data, and this is something that is like introducing you to Python is, okay, I create a variable that in this case will be named config with all this data. So I created a config variable that is, you see the curly brackets at the end, this is a dictionary. So a dictionary is just like a map where you have a key and a value. This key and value could be strings, could be integers, don't worry about this, but it's a mapping. So as you can see, I'm mapping a device name, a device type to BIOS. A host in this case is router A. The username is background and the password is background. So we have everything that we need. Then what we do is just instantiate this connection handler. We create an object that is connection that says, okay, I want to create a new variable that is a container. For this library, I want to connect to this handler, to this object with this config. It's in uppercase because it's a constant, it's not changing. It's just a well-known understanding in Python. So when this is done, we are connected to the device. We have not done anything, but we are connected. So what we have to do is try to interact with the device. Once we are connected, this object has some facilities that we are going to use. First, let's do a simple show interfaces. So it's one of the first things that you will do when you go into a device is just check which are the interfaces. So what is going to do this connection is, you see that there is a helper. If we do a dir on this connection, we are going to see that send command. And send command, you can understand, maybe you are already foreseeing that what it's going to do is just send the command and get the return of this command like you were doing in the CLI. So it gives you the option to automate this part. So we can run this command and we see that this is the return that we get from the device. And you can see that there is an Ethernet 0, Ethernet 1, Ethernet 1 is the management one, Ethernet 2 is empty. You see, there is nothing connected. Actually, there is a link because I mentioned you that background provisioned a link between router A and router B, but there is no configuration. That doesn't come by default. So if we want to go into configuration, in this case, BIOS has a config mode connection. We have created the connection in this case for BIOS, but the interaction, the connection, the config mode is exactly the same. Like is the same, the send command. So if we go into config mode, it's a bit of delay to go into this mode. You have to interact with the device. You have to wait for a bit, okay. And let's try to send a configuration. So we want to, for instance, we know which is the syntax of this CLI. You see that this is a basic automation. It's not something that is abstracted. No, we know which is the CLI. We know the language. The only thing that we do is automating how we deal with. So in this case, what we do is, okay, I want to configure the interface Ethernet 2 with this address because we saw that there was no configuration here. So let's run it. We are setting the command and we are, in this case, we are committing the change. What do we get? Now we finish into the operational and the configuration mode and we go back to the operational mode, the one that we ran before the show interfaces. So the point is now, let's do the same. Let's try to run the show interfaces to see if this is what we expect, if we see the IP configured in the interface. In this case, remember that was Ethernet 2, and this was the IP that we configured. So, you see, here it is. We have automatically, through Python, through the Netmiko library, we have interacted with the device. Things to notice, because we are going to move now to the second part. Notice that we are interacting with the device in a basic language that is just send command, and I have to know about all the syntax. It's up to me to figure out what is this command. It's not, I cannot say for this device, give me the interfaces or set this interface. There are other libraries that will give us these capabilities. But in this case, it's good enough. We know the language, we automated this, and we have the IP assigned. So this is the end of the first example, how we interact with Netmiko. If we want to keep moving a bit further on this path, we can go to the example 2. So here, we just do the same. We are going to create a base configuration. Okay, that is basically what we did before, but in this case it's dynamic. Why do you think it's dynamic? Because what we are going to do now, this exercise is going to connect to both routers. So when we connect to both routers, you see that if we compare this configuration with the one from the example before, I don't have the host. the host in this case is not defined. All the other variables, the device type, the username, and the password are the same, but the host will be changing. So this is the reason I name it base configuration. Then now we have to create kind of an abstraction definition. So in this case, I'm going to create just a local data, but this could be taken from everywhere. Imagine that from a source of truth, a place that there is this data description that we are going to implement. So we take data, and from this data, we then just implement into the code. So this is my definition of the source of truth of the network. You can see that there is also a combination of a dictionary, a list, there are strings. So basically, just summarizing, is a router A has these interfaces, that is only one, that is Ethernet 2 as the name, and the IP address is this one, and router B has this name interface, these interfaces, and this IP. You see that it's just describing your network. It's a simple description, but it's the one that we are going to use to automate all the process. So this example is using Netmiko in below, but the focus is in Jinja. Why Jinja is important here? If we are using Netmiko heavily, one of the main questions that we have to answer is how I create this kind of CLI commands. So you can see that this is just text. And if I can see this text, I can understand easily that if I want to create a lot of interface connections, the only thing that I have to change every time is the Ethernet name, the interface name, and the interface IP. So these are the only two variables that are meaningful for me. So you can notice that these are actually the two data that are defining as describing the network. So the goal would be that I will be able to generate the commands for this specific router dynamically. So just taking, okay, I am connecting to router 1, router A, I will know that the name of the interface will be Ethernet 2 and the IP address will be this one. And the same when I go to the next, to the router B. So how I go from one to the other, this will be a loop, iteration bit by all the different keys of this data structure. Let's go. So how this works? A simple example, one of the basic ones that you can start learning with Python. You see that what I mentioned before, the set interface Ethernet 2 and this IP, what I have to do is, okay, this is the text part, you see, the set interface Ethernet, and then there is a double curly bracket. This is just how Jinja understands that what is inside these curly brackets is a specific data that will be injected. It's not just text. This will be dynamically injected. And you see that there is a kind of a definition of this is going to be an interface, and in this case interface you have to understand that, or imagine, you can see the code actually. The interface is a dictionary that will have a name, that is this key, and an IP address, that is this key. So what I'm going to do is, having some data that will be injected into the template, I will render, that is the terminology of creating rendering the template in Jinja, and I will create as an output a text saying for router A the specific command for router A, and for router B the specific command for router B. So let's see this in action. As I mentioned, the template is as easy, okay. Let's run Jinja2 template, having this Jinja2 template that is a constant, that is this description. Imagine that this could be a configuration of 10,000 lines with different flips and backs and loops. A lot of different complexity could be done here, but this is just one liner. So then what we have to do is iterate through the source of truth. In this case, these are the source of truth, that is a dictionary that has two keys, router A and router B. So let's start with router A. So we are going to work on router A. This is the info for router A that I extract from the source of truth. And then when I am into the router A, what I'm going to do is, okay, let me check which are the interfaces, and this is a list. In this case, there is only one object, but in case that there were more interfaces, I could create more interfaces on the same run. So then I go into one interface that has name and has IP address, as I mentioned before, and I apply this template that I created. I just render, that this is the important name. Render is the one that says, okay, the interface that is within the template that it's here, you see, interface, this interface, what its equivalence is this one, is the object that I extracted from the source of truth. After that, what I have to do is, okay, I just connect to the device with the command and I just configure it. So these are the set of the commands that I am running just in one shot. That you can see that I create, you see the base config in this case is extended with the host because the device in each case is changing. In this case is router A. I create the configuration to the device, I go into config mode and I send the command, and finally I just commit this command. When this is done, takes some seconds, now I can check what is the interfaces now. So now I can see that, wow, Ethernet 2 has the IP from the example before and the new IP. So good to know. Now I can just disconnect from this device. I am done with the router A. Because I mentioned before this is just a loop, an iteration, now I am going to face what happens to router B. So to router B, I have a different source of information. I'm going to iterate over the interfaces that in this case is only one, the same data structure, you see the name, the address. Notice that this is important, data structure. You have to start seeing that having a data structure facilitates a lot the automation in the network. Having raw data like this data that you have to parse, imagine that here the number of spaces is different than this number of spaces. So automation will be more difficult in this case that if I have a structure that I can go directly and interact with. But in this case, this example for Jinja, we just render the same interface. The command that we render is this one, and we are just executing this on the router B. Notice another question is important here is that as I am building the configuration dynamically from a source of information, this configuration that is built can also be saved as a backup or as a reference. So it's kind of easy to integrate this code with other tooling, just not only to automate the network, also for reporting, for track analysis is also good to understand. Actually, what you have to keep in mind too, that having a source of truth and having the templating, the final result will be always consistent. If you change or the data source or the templating, you will have different results, but always consistent. This is gonna, I think that I forgot to press enter. And the final point is that we are gonna get the same configuration for router B. Okay, so if I do now the show interfaces, notice that this is not the same output. In this case, the IP in this case is 100, and this is 101 that shows router B, and you see the IP for Ethernet 2. When we finish the example, it's done. This is an example of how to put together Netmiko and Jinja templating. So, ready for the third example. Third example, we are going to explore Napalm. Napalm is a nice library for network that goes a step further. And this step further is that it's going to give you an extra level of abstraction. So you don't have to worry about the specific command. You don't have to know that to check the interfaces in this device, you have to do a show interfaces. The library will know for you. Let's check it out. First point, we have to install this library. Not all the Python distribution has Napalm by default. None of them have it. But actually notice that we had not to do this for Jinja, because Jinja is a template library that is used not only for networking, for other purposes. Let's go and install Napalm. Okay, this is taking a bit, not too much. Ready, installing all the dependencies, and here we are. now we can run the example again. First point, as we did before for Netmiko, let's do a dir for Napalm. In this case, the first thing that we have to do with Napalm is basically there is a base, there is a get network driver, there are a few stuff around. But what we have to understand is that what we want in this case is a specific network driver. You have to understand that the abstraction, the capacity to abstract comes with a price, with an effort, with a cost. Someone has to do this abstraction for you. So in this case, not all the drivers for Napalm have the same capabilities, but all the ones that are implemented should conform with the same format, with the same data structure. Let's see how it goes. So the first thing that we have to do is, like we did before, we just load the driver for BIOS in this case, and then we are gonna instantiate a device. The configuration in this case, you see that is shorter than the one before because the device type is already provided to the Napalm driver, and in this driver we provide this configuration just to get the device connection. When we have the device connection, there is an extra step in this case that is open this connection, so actually connect to the device. Before we have only created the class, we have instantiated the class in the local environment. So this is the point that takes a bit, so it's connecting to the actual device, in this case to router A, and when we do a dir device, let's check what we have available for the device. This is the important point in Napalm. Wow, a lot of things. So, and actually check what is the naming of these things. There is no send command that maybe I believe that is also available, but the important thing is that you can do something like get LLDP neighbors or get firewall policies, get interfaces. We don't have to know about the show interface command. We will be able to say, for this device that I am connected to, I want to get the interfaces, and this will do all the effort for you. So let's run it. There is a method called get interfaces IP. Let's see what we get. Oh, we see we are getting the same information that before when we did the show interfaces, or similar information, but notice that in this case it's not a raw output, it's not a string. The good thing here is that it's a dictionary. So it's a dictionary as a data structure that we could manipulate, that we could iterate, that we could transfer and handle and use for whatever purposes we have. We don't have to do a big effort parsing the output. We don't have to do because someone else has done. So this effort of parsing the output and giving you this is the beauty of Napalm, and actually is the effort that you have to do in order to implement a new driver. But it gives you a big benefit as a consumer of the library, because it doesn't matter if it's a BIOS or it's a Cisco or it's a Juniper. When you do a get interface IP, you will always get the same data structure, and this will be easy for you to take decisions from this information. There is also other methods like ping. So in this case, ping is just gonna do, okay, I am connected device. Remember that we are connected to router A. I am gonna ping the IP of router B. So let's see what we get. What do we expect from here? We expect to see also a data structure. And here comes. There is, when we do a ping, we don't get a ping with a raw data. What we get is a data structure saying the ping has been done, there have been sent 5 probes, no packet loss, with a round trip time, minimum, maximum, and all this information. And the result is this. So the point is that it's giving you a data structure that you can reuse, and it doesn't change from one device to the other. So this is the big difference between Netmiko and Napalm. Napalm goes a step further, but comes with the cost that if the driver that you are looking for is not implemented, it will be difficult for you to go forward. But there is always the option to contribute to the open source project and automate or just make your devices available or the method that you need, and also contribute to the community. So then we are almost in time, and we are we are missing the last exercise that for me is the most important one, because it's taking everything together. And this exercise is the one called assignment. So this is kind of a exercise, but before going there, let's do a simple stuff that will be SSH router A. Let me just clean the configuration. So in this case, I usually don't remember how to clean the stuff, so I have to check. I guess I have to go to the configuration mode. Okay, I'm gonna load the default config. Okay, so now what I done is I clean the configuration in router A. This is gonna be a good example. I still keep the configuration in router B, and you will see why I'm doing this. Actually, it's not important to save because I'm gonna destroy this later. So let's check what we have in the assignment. So the idea of the assignment is that you have you have to take an external JSON file that is defined here, that, as you can see, is just a data structure that similar to the one that I showed you before. It's a dictionary that has one for router A, one for router B, with a management interface, with the list of interfaces that we are going to configure. So you see that this IP is the same that we configured before for router A. And this IP is the same that we configured before for router B. But I have removed configuration in router A, but not in router B. So we have kind of mismatching configuration. So what we ask the script to do? What I want to do is I want to configure this network abstraction into the device. So let's see what I propose as a potential solution for this effort. Let's go into the code and let's see. This is just an example of a Python script. You see at the beginning that we are importing all the tooling that we are using, and it's not a long example, so I can go over it just to let you understand what we are doing here. So the first thing that we do is just we open the JSON file, so we get the network data from the JSON file. Here we have the dictionary that we saw before in the other file, in this case, or could be an external API, whatever. We import into the script. We create the driver that from Napalm in this case, just to make things easier. The device configuration, a simple username and password that are the ones that come for the demo. Then, as I mentioned before, I define a Jinja template, the same that we had before. The interface Ethernet, the IP, and the mask. I create the interface template, just instantiating this into Jinja. And then let's go into what is actually the code. You see, what I have is the network data, that is the one that we defined, and then I just iterate in this dictionary. And for every iteration, I get the key that is the router name. What I'm doing here is I'm tracking how many routers I have configured. I want to print something on the screen just to see that I'm going into here. You see, I am getting the host name, I'm getting the configuration of the interfaces, I'm connecting to the device, I'm actually opening the connection to the device, and I get the interfaces IP. What I'm doing this, because what I want is to configure IPs on the interfaces, but could be that the interfaces, the IPs are already configured. So I'm doing this effort because I'm gonna do an exercise before just to see if the the IP is already configured. So what I'm doing is, okay, these are the IPs configured. And for every time I am checking that if the IP is already there. If it's already there, I'm not gonna add it. If not, I am gonna get the configuration that I will finally deploy to the device. So what I am trying to say that maybe there are more there are better or more complex ways of automating things. But if you have to do the raw configuration that I am doing here with Python, you have to take into account all the use cases, all the cases that you will find through the path. The point is that sometimes it's difficult to get this point. You have to experiment it and handle different use cases. But you have to understand that, for instance, in this case, I don't know which is the state that I will find the device. So I have to understand what's the state, understand what is my purpose, merge both together, and just understand what has to be done. So this effort is the same effort that, for instance, Ansible can do for you, or other abstraction tooling can do for you. But we can do this in Python. At the end, someone is implementing it. So at the end, we are going to implement this. We are going to configure both routers, and we are going to do an easy an easy ping between both devices just to see how it works. So let's do a quick run of the script. You can get a more deep understanding of how this works, because as I mentioned, Python is easy to read and to write. So let's run it. This is also with some interactions. We are starting provisioning router A. You see, it's saying that the Ethernet 2 configuration is not ready, so we have to do something, because I noticed that I deleted the configuration, so it makes sense. And says, okay, these are the changes that has to be committed, because the difference between my purpose and what I have today, this is the difference. So this is the changes that will be committed. Then this is committing, and changes have been committed. So at this point, router A is ready, and now I'm checking router B. In this say, oh, the interface is already configured. I already detected that the IP is in place. So notice here that I don't have to do any change in the configuration. And at the last point, what I do is just check the reachability between router A and router B. So from router A and router B, the ping is successful and it works. Yeah, so this was the exercise for today. I don't know if you have any question. Remember that you have the Slack channel just to share any question, any topic that you would like to ask me. And I could go deeper on the code. But this is more or less the idea, the analysis of what we try to show today, that is a super simple basic interaction with Python. And obviously you can do a lot of complex things on top of this, but this is just a quick example that how to start building your own scriptings just to interact with devices that maybe is difficult to abstract because they don't support complex or more modern network protocols like netconf, YANG abstractions. In this case, we are not doing anything super fun or super complex. It's not rocket science. It's just do the same that you were doing usually with your CLI, but in using code. And just show something. I guess that the main point here is to see the difference between what Netmiko, for instance, is offering, that is a raw interaction with the device, that sometimes you need it because there are other tooling like Napalm that gives you an abstraction is not ready for that, and you don't have time to implement the abstraction for this. Then you have to go directly raw and do some kind of screen scrapping that everyone has had to do in his life. But I guess that is just a starting point. So we see a question in the chat from Costas. Thanks for your presentation. Exactly. So the question is, Salt and plus Napalm can do easily exactly what I described. Exactly. So this is the point, and actually it's interesting the point that what I have described today, there are other tooling that does the same. I'm not saying that this is the way to go for you. This is just an exercise, like an academic demonstration or purposes of what is going behind the scenes. So for your use cases, sometimes you don't have to do all this stuff. Maybe if you have to do this kind of stuff, you can just go directly with Ansible, or there are other tooling like Salt that can do more or less the same together with Napalm. But yeah, I think that this is a good point, that you don't have to take this as the best way of doing things. This is just an easy example for you to understand what's going behind maybe other tooling that you are more used to work with. I guess that a lot of you have been starting working with Ansible, and Ansible gives you this kind of abstraction, but behind the modules, what the modules are actually implementing is not this code, but is a code that is quite similar to this one. Okay, so yeah, if there are no more questions, remember that first of all, thank everyone to attend today to this session, that it was kind of introductory, and it was like a test for us for this new format, because it's not exactly the format that we prefer, because we want the face-to-face. Actually, this is the main goal behind NetBCN. But because of the circumstances, we have to do this kind of format today. But we are quite happy with the attendance and everyone engaged with the session, and hopefully it will be useful for you. So feel free to go to check in the in the meetup for NetBCN for new events, and I encourage you to join the Slack channel where we keep everything ongoing. And yeah, we are working for next events. That our idea was to go for a panel that will be a great exercise to discuss with different points of view regarding different topics that we have in mind, but maybe depending on how this goes and how long it takes, we are gonna maybe try other online tooling that will facilitate the actual interaction with you. So thank you very much for your attention, and just keep in touch. Thanks.